Welcome everyone to another Winston's Maths, and today we have weirdness, whacking balls and wizardry as we explore place value. So if we're thinking about place value, it's really important that we're confident about our place value columns. So I'm going to show you something that you can make to help you remember and use your place value columns. And all you need are 2 sheets of paper. If you've got different colours, fabulous, but 2 sheets of white paper would do just as well. So first you're going to fold one of the sheets about 1/3 of the way along its length to make a little pocket like this. And once you've done that, then you fold it the other way in half. Open it out and fold each of those in half again. Into the middle so that the edges meet in the middle. And that gives you 4 sections, and each of those you're going to fold in half again the other way to make a concertina. A bit like when you're making a fan when you're in the younger classes. So you make a little fan using the folds that you've already made and folding each section in half. So you should end up with 8 sections. And just to be clear, we're going to mark those with a pen, and I'm going to label them thousandths, hundredths, tenths, a decimal point, ones, tens, hundreds, thousands, 10,000s. So let's get on with that. And here we have our pockets, but we need some numbers to go in them. So I'm going to use my other colour to create 2 sets of digits from 0 to 9. This time I want to split my length into 10. So I'm going to use my ruler and try and work out roughly how wide that would be. And once we've got our numbers cut out, we can use them in our place value concertina to create bigger numbers. Once we've got our digits cut out, I should say. So if I'm thinking of a number with 110, 4 hundreds, 3 ones and 5 tenths, I'm thinking of 413.5. And I can use this in other ways as well. You might remember that when we multiply by 10, 100 or 1,000, our digits move up the place value columns. So I'm going to put a little arrow to remind me that when we multiply, we move in this direction. And when we divide by 10, 100 or 1,000, we move down the place value columns. So I'm going to put another little arrow in to remind me the direction that we go when we divide. So if I wanted to multiply my number here by 100, you might remember that we move each digit in this direction 100 signals that it's 2 places. The 2 zeros signal to me that I'm going to move 2 places in this direction. So here we go. 1, 2, 1, 2, 1, 2, 1, 2. And remember, I need a place holder because I've got a space between my number and the decimal point. So if I multiply 413.5 by 100, I end up with 41,350. Have a go at doing some of these for yourself. You can use your concertina to solve all sorts of problems. Ow! What is this? Ah, a problem. It says, guess me. I am a 3-digit number. My tens digit is 6 less than my ones digit and 1 less than my hundreds digit. If you multiply me by 7, the estimated product is 1,400. What number am I? I need my concertina. So this is a 3-digit number, so I'm looking at hundreds, tens and ones. I know that the estimated product is 1,400 when I multiply my number by 7. So I'm going to divide this by 7 and see what I get. I know that 14 divided by 7 is 2. So 1,400 divided by 7 will be 100 times bigger than that, 200. So I know that my number is going to be close to 200. So I'm going to pop a 2 in the hundreds column. Now it says my tens digit is 6 less than my ones and 1 less than my hundreds. So I need 1 less than the hundreds to go in the tens, and it's 6 less than my ones. So this is 6 less than the ones. So that must be a 7. So I think the mystery number is 217, but it said that an estimated product, if I multiplied it by 7, was 1,400. So let's do that. If I estimate the product, well, 217 is close to 200. 200 times 7? Well, I know that 2 times 7 is 14, so make it 100 times bigger. 200 times 7 is 1,400. Boom. So I used my concertina to guess the number. See if you can guess my number now. So when we're learning about place value, it's really fun to make up games, create games to do with a target number. We've done these in school before, but we can create a target number and think about ways that we can get to that target and reach that target. So I have an able assistant here again with my random number generator. Now you could use a spinner or a real random number generator. We've got cards. Okay. You can choose. I'll hold them out. Could you please choose a card? That one. This one is a 4. If you're confident with your decimal places, you might include a decimal point. If you're not, stick to hundreds, tens and ones. But I'm going to do tens, ones and tenths just to be a bit more interesting. So what's our second digit? for number 1. I'm going to have tens, ones and tenths, so I need a decimal point, and my tenths digit will be
that one.
Which is?
So we've got 4, 8 and 5.
So the target number is 41.5. Now you can use clothes goals, you know, a couple of jumpers to make a goal. You can use hoops, you can use ropes, you can use garden pots, anything to make 3 goals. Now I've just got circles drawn on the wall here and I've labelled them tens, ones and tenths. Now we're going to use a football to try and get as close to the target number as possible. If you're playing on your own, you can beat yourself, but if you can find a willing housemate to play with, you can have a competition. Now, I need to decide how many goes we can have each. Now, we could have 10 goes each, but to make it interesting, I'm going to add up my digits and I'm going to use that number as the number of goes we have each. So 4 plus 1 plus 5, we're going to have 10 goes each. That's what I would have suggested anyway. So, can you get the number by kicking the ball 4 times in the tens, 1 time in the ones and 5 times in the tenths? Every time you kick the ball into one of these goals, I will make a tally so we know what number you've scored at the end.
Okay.
10 goes, off you go. Go number 9. And go number 10. Oh, hang on, that was a throw. You kicked that ball, young man. What a scamp. Back to the marker. Oh, it's all gone pear-shaped now. Your last go. Come on, make it count. Hey. 10 goes. And your number that you have created is 4 in the tens column, 0 ones, and 3 tenths, or 40.3 for 10. My turn.
Go number 9.
Oh no! Raise it up.
Come on, Mum. Final go. Go number 10.
Okay. Come on. Come on. Yes!
Yeah!
What was my score?
So, your number was 3.
Oh.
3 in the tens column, 0 in the ones column, and 0 in the tenths column. So Mum's number is 30.0.
Which is the same as?
30. Okay, so as we all know, I got 40.3, and as we sadly all know, Mummy got 30, which means I was 1.2 away from our original number, 41.5, and Mummy was 11.5 away from our number, 41.5, which makes me the winner of this round. Yay!
Come for some Winston's wizardry and magic. Come to my woodland glade. Come. and take a seat. So, young sir, would you please choose a 2-digit number? You can do this at home, where your 2 digits are different digits, please. Yes? Now, please, would you reverse those digits to make a new number? Yes? Now you should have 2 2-digit numbers. Can you please take the smaller number away from the bigger number? Now, please, if you have more than 1 digit in your new number, add your digits together. And the number that you have is number 9. I bet you had 9 at home as well. So let's see how that works. What number did you pick to begin with?
75.
You picked 75. So when you reverse the digits, you got
57.
and you took 57 away from 75, which gave you
18.
Okay, 18. And when you added the digits 1 and 8, you got
9.
boom. Now, you might have worked out that it always ends with 9, but it's a really great trick to try on anybody you're in lockdown with. But can any of you tell me, why does it always work? Answers on a postcard. So for those of you who like a challenge, here's some challenging ideas. Now, when we think of place value, we think of our place value columns, like our concertina. And we also think of our digits. Now, you're used to having 10 digits, 0 to 9. But on the subject of 9, what if we lost 9? What would happen if we lost a digit? How would that change our number system? Actually, there is a thing without the 9. It's called base 9. If we only had the digits 0 to 8, and it's called base 9, what can we do with base 9? Let's have an explore. So we've still got our numbers 1, 2, 3, all the way up to number 8. That's all as normal. But without 9, our number 9 becomes this. This becomes 9. This becomes 10. This now becomes 11, and so on and so on. This here becomes a 9 and a 2, 11. So this column here, instead of being worth 10, is now worth 9. And this column here becomes 9, lots of 9. That changes things completely. I wonder how far we can count in base 9. So let's see how far we can get. We know our first digits. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I say that represents 9 in our normal base 10, we call it. 10, 11. This becomes 12, 13, 14, 15, 16. Let's make some extra paper here. see this is going to be a long investigation rather than wide. 1, 9 and 8 becomes 17, and then 9 and 9 is no, there is no 9. I cannot write that. Instead, I have 2 9s and 0 1s, which is worth 18 in base 10. 2 9s and 1, and so on. I wonder if you can carry that on and see how far you can go in base 9. Not only can we count in base 9, but we can add and subtract in base 9 too. So we had a go at adding in shillings and pence a few weeks ago. Let's see if we can add in base 9. It's not dissimilar. So I've got some sums here. Remember, they're called sums if they're addition. But I'm going to answer these in base 9. That means there are no number 9s. If I want to write 9, I have to write it 1901s. So let's give it a go. First, we add the ones column. 3 plus 2 is 5. 5 plus 7 is 12. 12 plus 5 is 17. Now 17 is 1 9 and 8 1s. So that looks a bit different. 2 plus 4 is 6. Plus 1 is 7. 7 plus 4 is 11. 11 plus 1 is 12. But we write 12 as 1 9 and 3 1s. 1 9 and 3 1s. So our answer is 138. Not what you would normally get when you answer in base 10. I've got 2 more sums here. You can have a go at those in base 9 if you think you can, but remember, the number 9 is not represented with a 9, it's a 1 and a 0. So our columns become 1s, 9s, and 9 times 9s. Very different to what we're used to. Have a go at those. And perhaps you might like to tell me what this number represents in base 9. If you have 3 9 times 9s, 4 9s, and 7 1s, I'm actually going to use the symbol there just to help you remember. What would this number represent? Have a go at that one. So this week you've got lots to think about. Perhaps you could make up a game to reach a target number. Perhaps you can make a concertina place value device. Perhaps you can use it to tackle some base 9 questions. And remember, try the trick out on somebody. They'll be really impressed. So have fun with your place value this week, and we'll see you again soon.